In this part of the tutorial, we'll run through the full structural analysis and review the design results and make any necessary changes to the model. To get started here, let's go ahead and push the Analyze button, and it will run the analysis and design. So you can see how quickly it goes through every calculation on screen, showing us just detailed information of what floor was designed. So on the left side of the screen, we can go through and see information on what worked and what did not work in the model. So you can look through your beams, bearing walls, anything that turns red shows us there is some kind of a failure. So we can look down the building to see what's going on. So let's start first thing with a roof beam. Double clicking on the beam itself, we see that the definition is red, and if we jump over to the sizing tab, this beam size is currently failing. So we can see here, we see the failure was the beam size, and it shows us a calculation on the right side. So we can see specifically this is a calculation failure on bending, and as I scroll down I see both bending, shear, and some of the deflection analysis. So the size right here tells us beam failed, and I see the list of all of the beams that were tried. So let's go ahead and make some decisions on what the beam here is. So we can compare. So there's a couple things right now. It's trying to choose the width of the wall as a 4x4. We could change this manually to something else. So we could switch it down to maybe try a 4x6. That also works. You can also make comparisons, like you could try to do a glulam, for example, and see if that would run. We can force a glulam in the same width, roughly, and see what happens there, and that'll get us in the same land there. But I'm going to choose go back to the one that I have, a 4x6, and I'll go ahead and say apply changes, and it will now use that. So I'm going to every time I run the analysis, I can click on that one here. You'll see that it stopped being red, and I can go over to sizing, and this is an individual check that's happening with the summation. So we can either force it to be again a 4x6 or go from there. So we have now solved those two beams, and we can move on. Bearing walls, let's take a look at the bearing walls. So looking at the bearing wall and looking at the sizing, we see here we are failing this stud. We're using a 2x4 stud, and we're failing. So this currently is spaced at 16 inches on center at 10 feet. So that we can see all the calculations that are shown, gravity, sill plate bearing, as well as our lateral forces down below, checking components and cladding out of plane wind on the stud. What we can do instead, we can put a 2-ply, so 2 studs at 16 inches on center, recheck that, and that is adequate for our design. So I can say okay, and I don't have to do every single wall like that. We could just highlight all of the walls at once, use our edit group, and I can come in here and change them all to be at the same time. So I can make them all be 2 counts right there, and we'll say that they're 16 inches on center, and apply it to every single bearing wall we have. Now when we rerun the model, we can just do a quick rerun, and it now shows that these should be passing. And now it shows that these are all passing. Let's take a look at the shear wall. So if we open up this shear wall, we can review its results. Shear walls, if we go to the sizing tab, what we'll find in here is being sized based on a mark. Mark 11 has a certain capacity on that shear wall. So let's take a quick look at what that shear wall is. So I'm going to go back into the database, and Mark 11 right here shows us that Mark 11 is this wall, and that is a 3/8 thick panel with 8 penny nails at 3 and 12 inches. And that's the nailing pattern. And that has a certain capacity as well as a certain stiffness. We're showing that here in this dialog as well. So we can see here when we go back to that building layout, we have a Mark 11. This database is editable. So we have other videos showing that, but right here, this is the current marks that are defined inside of Lava. So going into that building layout, you'll see here we have Mark 11, one-sided panel, and its capacity. What we also will see is the hold downs. Hold downs are sized for you automatically, and you can find that hold down right here. We're allowing it to be the offsets for those posts and anchors, and you'll see below all the calculations for the tension force and what was sized for that spacing. We can jump over to supports, and that's the failing mechanism right here, and we see that both of the supports are failing. So we can switch that we can adjust the depth here. So let's take a quick look. We are looking at our current problem and we scroll down. We can just see a little bit about why it's failing. We see sill plate bearing capacity, so we can see that. What we can change here is that depth we're using is 3.5. We can increase that depth. Let's switch it to 7.25 and rerun the analysis. So now it lets us actually size this as a 2x8 wall. And we're going to actually switch this, the unbraid, let's switch that width as well as that depth. And now it's a 4x8 that's using instead. So the unbraced access is going to be giving you options here for depth, width, or fully braced. So we're telling the program now that we will turning that on its side and we'll be bracing it at its width. We'll go ahead and run that analysis and see that a 4x8 works for both of them, and then just apply those changes and say OK. Let's take a look at the lower level. So if I jump to one of these shear walls and I'm going to go to its sizing tab, it is being sized also for a Mark 11. Let's go to the hold down. What we'll notice is because we copy and pasted these walls from above, they have the same floor to floor height from above. We can adjust that back to a concrete pour, so we know that the program is going to size hold downs that work for a concrete foundation level. So I'm going to go ahead and resolve this and I'll get a different hold down. I may want to choose a specific hold down, and I can do that by going into this here and finding a specific hold down. So in this model, let's go ahead and we can pick a specific hold down and we will find one. Let's go ahead and pick an HDUI 5 and see why that would not work. This doesn't work, dude. So confusing. Why does that not work? Let's go to the hold down tab and we can see here that we have hold downs currently sized for us, but the program is specifying a hold down based on the fact that it's at 6-inch floor to floor, which is an upper level. And that happens because we copied these shear walls down from above. So if we had drawn them on the lower level, it would have recognized that it's on concrete, but we have copied it. So we're going to just switch these to be one pour 2.5 KSI concrete that it's sitting on and rerun the analysis, and it will pick a hold down that is appropriate for that scenario. We can also go over to the support tab and adjust any failures here. So we see that we also are having problems on this support and we can adjust that. But before we jump, let's see. I'm going to not jump there. So I'm going to go back to hold down tab, and we can also go ahead and copy this to every of the elements on this level. So let's go ahead and apply those changes and rerun the analysis, and we will get hold downs appropriate for that. We can pop over to the supports tab. We see some failures here. We have a few of these failing here, so we can adjust these if we need to be. We can see what the program was sizing for. So up to a 4x4 did not work. And we can go ahead and switch either from the depth if we want to try to do something in the other direction like we did there, a 2x8. We can actually switch that to be a 4x8 if we need, but let's go ahead and check that. You can also go and switch maybe to a timber and you'll see a 6x6. Depending on what kind of size walls we're having down here, we can adjust that. So I'll go ahead and change these both to be timber, and I will force them to be 6x6s. There we go. Say OK and move from there. Let's go ahead and change the post on these two since that's the same problem. We'll go ahead and go to the sizing tab and adjust their posts. So we'll switch those to be timber, and we'll say on both sides we'll create these to be the post size 6x6 and apply changes and go ahead there, and we'll rerun the model and we should be able to see all of these being corrected. Lastly, let's address these beams on this lowest level. We'll jump over to the sizing tab and see what's going wrong with those. And we also see here that we have support problems. So these are large span beams and we need to have larger posts put underneath them. So we can do something very similar, switch this to be the timber setting, adjust that, and see a 6x6 works. You can apply changes, and we also have a dial here just to jump to the next wall and make that same change really quick. So we just switch these both to be the timber size and then go from there. Apply changes and go. Now that the model is completely working, we can go to our report. So we have no failures. We're ready to see the report running. You can go over to the report tab. This is always happening in the behind the scenes. Just click the print preview. And what you'll see is that there is a preview that's building in the background, and we're going to be able to flip through all the pages. We have specifics of things that are turned on and off on the left side by default, but you can turn on different things if you need. So we'll jump across, down the pages. So first thing we see is the cover page. This cover page comes right off of the pages that we had here that we assigned single family home, Modesto, California, with our logo right there. So looking at that, we see all that information right here. We also see the project description as well as the plan description, and then a table of contents, which makes it very easy for us to follow exactly the pages of this model. So we can keep going, and we see the load combination that were created. So we see IBC24 that created all these different load combinations. And then we jump to the material specification. If you wanted to, you could put information inside of that. This is blank, and if you choose, you can turn off this page if this isn't being used. So on the left side of the screen, you could turn off your material specification and just rerun the print preview to have it disappear. See the specifications. I'm going to jump to shear wall schedule. This explains what each mark is. Ready for construction, you have exactly what the description is. The nail spacing is listed there, as well as the capacity. You've got your manufactured panels as well. These are the Simpson strong walls, and then our hold downs that were needed for this model. So I keep going. I have a list of all of the loads, including all the gravity loads that were used for my roof, floor, my walls, and interior and exterior. We also see a echo of the building elevation. Continuing, we see a plan view elevation for the gravity system, as well as the lateral system. We'll keep going for that each floor. This picture is automatically fit onto the page based on the size of the building. So you can see how it nicely sits there for your review. We can jump, so this is the joists. We have a page here, just like materials, where you can put information on this for your reference. So I'm going to jump to the beams tab. The beams tab shows us a specifics on what the beams calculations were, what their posts are. The beam analysis shows us the loads that were applied, dead, live. This is for live for the roof load, LR. We see all of the distributed load on that beam, and then we get to see the shear check, moment check, and deflection check. That's listed out for each beam, as well as we see the supports. Those are the post analysis, and we see the posts that are being designed right here, plus the load combinations that are governing and the duration factor right there. As we keep flipping through each beam, we can see that if there's point loads on it, we will track those and see all that information in a clean, concise way. Now, bearing walls are next. Bearing walls are not shown by default, and you can go ahead and turn them on. We turn them off by default because you may have a lot of bearing walls. So to turn them on, you just go to your preferences and you turn on go to building layout, bearing walls, and you can say print and report. You can apply that and go from there. And then on each bearing wall that you would like to display, maybe pick the worst case, something like one of the ones that are controlling. You could come in here and say print and report. So if we go ahead and do that on a couple on the upper level and the lower level for maybe the controlling elements that we have, we'll see these in the report. So I'm going to go ahead and just rerun that analysis, go back to the report and rerun the report, and I'll see these now bearing walls are in my report. So now let's go to the bearing walls, and we'll see here we have a bearing wall displayed here as the gravity loads and the lateral loads on there. Those lateral loads are those components and cladding wind loads. So you can see the worst case scenario of the dead and live coming from the roof, and then we see the similar thing on the lower level. So we're going to go ahead and get to the next part, which is going to be our lateral design. So let's click through that. You can click right directly on there. It'll jump to that section. So we see here, this is the seismic calculations for each floor level. It calculates the weight, height, and then lastly, we're going to get into the shear applied into that wall, into that level. So we see that for each level. And then we see that in each direction. Note that we are doing things in two different directions. So we've also got that for the wind calculations. You'll see general calculations and showing exactly what code references are being used for that main wind force resisting system, and then the loads that are applied in each direction. So in the we'll see the windward and leeward forces on each side, and then we will jump to, continuing on the way, we're seeing the wind pressures. This is going to be very similar to your input that you put into the model, and then we can also go into the calculations here. We see that it's based on a flexible design. And then we'll see our shear lines. So shear lines are going to be an important part of the design information. You see each shear line, the total force in there for the earthquake and the total force in there for wind, and then the total wall length per shear line. So this is a great place to understand the quality check of whether you did your analysis in the way you thought you did. We have different shear lines, and we have about with the approximate load that we're seeing in each direction. So we can see that as we go down, we get a total force in there. It echoes back a little bit of what we saw in that seismic forces. So our total weight, and then lastly here we're seeing the total force going into those shear lines. And then we jump into the actual shear line analysis. So we can see each shear line distributes load into that shear wall. And we see it broken in for both earthquake and wind. Depending on what is governing, you'll see the information there. So let's pop right back here. On that one page here, you'll see that you've got earthquake and wind displayed here, and then you'll see it on there, and we see the total distribution of load across that drag force there. So you'll have that maximum drag force is shown here at 2,093 pounds, right at the edge of that wall. So we can see all that information going in here to each shear wall, what shear wall got that load, and what the calculations came from there. And then you also see your worst case shear wall. And then the program is also running a drift check to make sure it's meeting that criteria. So if you have multiple walls, you'll see multiple walls along that shear line. So we keep going down the path, and then we'll also go down. The shear walls show us a very similar table where we see the name of the shear wall, the mark that we had originally shown in the schedule, and then we go into more detail on what is the chord force or the post at the edge of each wall, as well as the connection at there. So we can see each chord and then the connection of that hold down or strap. So we can go down below here. We see this is the wall. And we get into more details on how we sized this wall, the total force that went into the wall for both earthquake and wind. And then you have also your downward force listed here too, your shear check, and then we give you the code references for these checks, as well as the uplift, post check, and then lastly our deflection check. So these are all being met in order to size that wall properly. You can keep going all the way through every single shear wall to get all the information. That concludes the video for the results. You can go to the website to our help file, find the link in the description below to find specifics on how to download this exact example. Thanks for watching the video, and check out more on lavabuild.com.